Today's video is on 5.3, solving quadratic equations by finding the square root. So before we get into solving, let's go ahead and review how to simplify radicals, so how to simplify those square root symbols. There's two ways you probably learned how to do this. First one is factor trees, second one is just using perfect square factors. Kind of a catch-22. Factor trees are easier, but perfect square factors are quicker. So you got to kind of decide which one is the best method for you. We look at the square root of 25. Now that's a perfect square. If we have a perfect square, then we don't have any radicals left. The square root of 25 is just 5. We look at the square root of 8. 8 is not a perfect square, so we're going to break it down, and I'm going to use factor trees. 8 is 4 and 2. This is 2 and 2. And hopefully you remember the phrase, a matched pair makes a perfect square. So 2 times 2 is 4. So every pair of numbers gets to go to the outside, and then you have a 2 left over on the inside. So that becomes 2 root 2. 18 again, not a perfect square, so we've got 9 and 2, 3 and 3. We've got a pair of 3, so the 3 gets to go on the outside. The 2 is left over, so it gets to stay on the inside. It can't go outside unless it has a buddy. So kind of think about an elementary school. When you're either going to the bathroom or you're going to the playground, you have your buddy. A lot of times you have to hold their hand. So this is kind of like that. If you want to go outside, you have to have a buddy. If not, you have to stay on the inside. 96, not a perfect square. If I break that down, I've got 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. So I've created this big long tree. I'm only going to look at the numbers on the outside. Those are the leaves. And I match up those. So I've got a pair of 2's there, a pair of 2's there. I've got a 2 that's left over, and I have a 3 that's left over. Those don't have buddies, so they have to stay on the inside. I do have 2 pairs of 2's though, so there's one pair going to the outside, there's a second pair going out, and there is the 2 and the 3 left over on the inside. Now these are prime factorization, so it's all multiplication. So this is a 4 on the outside and a 6 on the inside. Now that's using factor trees. Let's go ahead and try this one using perfect square factors. What I want to do is I want to look at 96 and I want to find a perfect square that is within that. So I think about all the numbers that divide 96. 4 is 1, but I think I can go bigger. 96 is actually the product of 16 times 6. So 16 is that perfect square factor that we are talking about. Well, the square root of 16 is 4 with a 6 left over on the inside. So you can see that this is much faster than a tree, but I think it's a lot harder to see. I normally only use this method if it's an obvious number like 200. I can break it into 2 and 100. Otherwise, I normally do the factor tree just because it's easier and it's kind of less thinking that you've got to do. Alright, moving on to the next one. We've got the square root of 4 over the square root of 16. We're dividing. Good thing that we've got perfect squares though, makes our life easier. We've got square root of 4 is 2, square root of 16 is 4. Don't forget to reduce that fraction down to 1/2. Alright, enough for simplifying. Let's go ahead and on to some operations. We are multiplying. When you are multiplying radicals, what you need to remember is location, location, location. Location is the most important thing. I'm going to multiply outside numbers together. 2 times 3 is 6, and since they're outside, they're going to stay outside. And then I'm going to multiply inside numbers together. 3 and 2. Since they're inside, they stay on the inside. Then I have to double check. Square root of 6, can I break it down any further? We do our factor tree. 3 and 2, no matches. So 6 root 6 is going to be our final answer. Go to the next one. Outside numbers, 2 times 3 gives us 6 on the outside. 5 times 6 gives us 30 on the inside. We've got a pretty big number there. Bet there's some matches. 2 and 15, 3 and 5. Oh, we were fooled. 2, 3, 5. There are no pairs here, and I can't break anything down further. So this is simplified all the way as well. Moving on. Outside numbers together. 5 times 3 gives us a 15 on the outside. 6 and 8 on the inside. That gives us a 48 on the inside. We break this down. 4 and 12. And it doesn't matter how you break down your tree. This is 4 and 3. Now, I could go ahead and break each of these down 2 and 2, but I have a pair of 4s. So I could break it down further, but I don't have to, because remember, you're just looking for a pair with a 3 left over. So 48 becomes 4 root 3, but I can't forget about the 15 that was already out there. So it's 15. Now I have to think about what am I going to do with the number that's already there and the number I'm bringing out. Since I'm multiplying 15 times this radical, I'm still multiplying it, so 15 times 4 gives us an answer of 60 root 3. Go on to the next one, root 2 over root 4. Well, I can't break down 2 any further. Square root of 4, perfect square. Not as hard as it looked. Alright, so now we get to root 6 over root 2. Remember when I said location is the most important thing? Location, location, location. 6 is inside and 2 is inside. Because they are both underneath a radical, I can put them underneath one radical. So 6 and 2 are both still underneath radicals, but I put them under 1. 6 divided by 2 gives us the square root of 3. Alright, so now I have a new problem. I can't break down 2, I can't break down 3. Well, this is not inside a radical, so it doesn't matter anyway. But 3 can't be broken down any further. One of the rules of radicals is you cannot have radicals in the denominator of your fraction. So that root 3 can't be on the bottom. What we have to do is something called rationalize. And hopefully you remember rationalizing from Algebra 1. What we want to do is we want to get rid of that radical. The only way to get rid of it is to make a perfect square. A perfect square comes from a matched pair. So I need a pair of 3's. So I'm going to multiply by root 3. Now just like when we solve for x, if you add to one side, you got to add to the other side. If you multiply to one side, you got to multiply to the other. So I'm going to multiply top and bottom by root 3. 2 is on the outside, 3 is on the inside. So those numbers don't mix and it stays as 2 square root 3. If I wanted to do this the long way, root 3 times root 3 is root 9. Square root of 9 is just 3. Or we know that anything times itself is going to give us, get rid of that square root sign because I've made a pair of 3, so it's a 3 on the outside. When I look to reduce this, I have to look at numbers in the same location. So outside numbers stay together, inside numbers stay together. The two outside numbers cannot be reduced, so 2 root 3 over 3 is our reduced answer. Now, let's go back a couple problems. Let's say I saw this here, and I put it underneath one radical. So I put 2 over 4, that reduces down to 1/2. You can't have a fraction inside a radical either. So I would break this into 2 pieces. So we put them together in this one. We're taking them apart in that one. So sometimes you got to put them together, sometimes you got to take them apart. Kind of got to shuffle your puzzle pieces until you get something reduced. Square root of 1, 1's perfect square. So now I'm left with 1 over root 2. So let's say you didn't see what we saw right away. Well, then you just created more work for yourself. We rationalize, and we've got root 2. Root 2 over root 2, or root 2 times root 2 is root 4, which is just 2. And you see that we ended up with the exact same thing that we did up there. A lot of problems can be approached in a lot of different ways. There's no right way, no wrong way. Some ways are faster and some ways are slower. So just remember your rules. You can't have a fraction under the radical, and you can't have a radical in the bottom of the fraction, in that denominator. If we want to go, let's go back to this one too. We could do this another way. If I rationalized right away, and I multiplied both top and bottom right root 2, I would have gotten root 12 over 2. And then I would have broken this down, 4 and 3, 2 and 2. This would have become 2 root 3, because there's a 3 left over there, over 2. 2's canceling, leaving us with the exact same answer. So don't freak out if you don't necessarily approach it the same way, if everyone approaches it the same way, because there's lots of different ways to do it. Okay, so what I want you to do is you've got 3 problems left on the front of your sheet. I want you to press pause, and I want you to try to work through those 3, making sure that all rules are followed, that there's no radicals underneath the fraction and there's no radicals in the bottom. Make sure that every radical is broken down as far as it can go. Okay, let's see how we did. We rationalized for our first one, and we get 6 root 3 over root 3. Location, location, location. The 6 and 3 are the two numbers on the outside. 6 divided by 3 gives us 2. On our next one, we rationalize. 8 times 3 gives us 24 on the inside because 8 and 3 are both on the inside, over 3. I break down 24. I get a pair of 2's that goes to the outside, and I've got a 2 and a 3 left over, which gives us 6 on the inside. Hopefully no one made the mistake of reducing the 6 and the 3 there. 6 is on the inside of the radical, 3 is on the outside. They're not in the same location, so they cannot be reduced. And we go on to our last one. Multiply top and bottom by root 8. So we've got root 24 on top, 8 on the bottom. You could have reduced the 2 and the 8 from the beginning and gotten 1/4 over root 24. Doesn't matter. We just did root 24, so don't waste your time doing the factor tree once again. We know that root 24 is 2 root 6, so I did, because I didn't reduce my fraction. 2 times 2 root 6. 2 times 2 gives us 4, and then I reduced the 4 over 8 in the last step. Either way, you would still end up with the same answer of root 6 over 2. Now, after we've reviewed everything from breaking down our radicals, now it's time to use this to solve a quadratic. We want to solve for x here. Well, if I want to solve for x, hopefully you have not forgotten everything that we've talked about recently. We've got 3 pieces, an x squared, an x, and a number. If I'm going to do this one, I'm going to solve by factoring. So I'm looking for 2 numbers that are going to multiply to the outside and add to the middle. And we've got a positive product and a positive sum, so I know it's plus plus, and that's going to be a 3 and a 1, equals 0. Once I have that, I'm going to use ZPP, the zero product property, to get x is a -3 and x is a -1. When we go over here, I don't have 3 pieces again. I can't solve by factoring. So I've got to think about, what am I going to do? I've got an x squared equals 144. Well, the opposite of squaring something is taking the square root. So I take the square root of 144 and I get 12. Now that's not necessarily our answer. Yes, if I square 12, I get 144. However, there's also another number that I can square to get 144, and that's a -12. Because when I square that negative, it cancels out to give us a positive answer. So when you solve this kind of setup, if you're solving for an x squared and just a number, you can't forget that plus or minus sign. Very, very important, because that positive negative, we don't know if it was positive or negative because we're squaring it. Same thing here. We square root each side. Unfortunately, 72 is not a perfect square the way the first one was, so we have to break it down. Again, I normally use our factor trees. We get 3 and 3, 4 and 2, 2 and 2. We've got a pair of 3's, we've got a pair of 2's with a 2 left over. That means we're going to have x equals, we've got that plus or minus sign because we've got an x squared. We've got a 3 times a 2 on the outside with a 2 left over. So x is equal to plus or minus 6 root 2. Next one, it looks similar to the last one, but I'm not going to do this because I'm not going to square root 2. Before you can solve for an x squared, it has to be isolated, just like with an x. So we move the 2 over by dividing it, because we're multiplying by 2. The opposite is dividing. We've got 81 square root. Nice, 81 is perfect square. Don't forget your plus or minus. I bet you can guess for the next one. If I want to get x squared by itself, I subtract 6, and I've got x squared is equal to 36. Nice times perfect square, so when I square root each side, I've got plus or minus 6. Next one, it's just like solving for x squared. We're going to add 5 first. So we've got 2x squared is equal to 20. Then we divide by 2 to get x squared is equal to 10. Now to get x by itself instead of the x squared, we square root each side. We've got that plus or minus signs, we can't forget that. 10, that's 5 and 2, no pairs. So we can't break that down any further, it's just plus or minus 10. Okay, Now this one's a little bit different. We want x plus 5 quantity squared. We want to get to that x, but that x is trapped inside of those parentheses. So we're going to divide by 2 on each side. And we've got 16. Now still I can't get to that x inside because I've got that quantity squared. To undo squaring something, I have to square root. So I've got x plus 5. Now I had a quantity squared equal to a number. So I don't know if that quantity inside was positive or negative. So I've got to do plus or minus 4 on that right hand side. We subtract 5. So x is equal to a negative 5 plus or minus 4. If you give me this as your answer on your quiz or your test, you will lose points. Those are numbers. You can combine those together. A negative 5 plus 4 and a negative 5 minus 4. So that gives you a negative 1 and that gives you a negative 9. So your x's could be a negative 1 or a negative 9. You've got 3 problems left. Following the model we just did, let's see how much you got. So do the next 3 problems and then leave the last one for the end. Alright, let's see how you did. In the first one, we divide by 2 first to get 8, then we square root each side. Because we square rooted something that was squared, we've got a plus or minus in our answer. We break down root 8 to get 2 root 2. Make sure that your radicals are always broken down as far as it can go. Then we want to get x by itself, so we add the 2 over. 2 and 2 root 2 are not like terms because one has a radical and one doesn't. So I keep it as 2 separate pieces, unlike the last one where I broke them apart and I had 2 completely different answers that were simplified together. Next one, we have to subtract 4 first and then divide by 3. We want to get into that quantity, so I've got to isolate the parentheses. Once I've got the parentheses isolated, we square root side. And because I square root, I have to have plus or minus. Add 2 to each side. Again, we've got a number and a radical. They're not like terms. So we've got 2 answers. One is a 2 plus root 7, and one is a 2 minus root 7. 2 completely different answers, but we can write them as one just using a plus or minus sign, as long as they're not like terms. When we go down to our last one, we divide by 4. When we square root 4, that's a perfect square, so we get plus or minus 2. Now, I don't have any radicals left, so I subtract 3, but now that's a negative 3 plus or minus 2. Those are 2 different pieces there, but to get x by itself, I've got to divide by 2. So this is the fraction I'm left with. I've got 2 circumstances, one when I add 2 and one when I subtract 2. That's going to give me 2 separate answers of a negative 1/2 and a negative 5/2. Alright, last question. What is the difference between the square root of 36 and x squared equals 36? Because there is a huge, huge difference. Think about it. Press pause and so you can think about it for a second. Alright, so the square root of 36, this is equal to 6. I'm evaluating. So big difference here is I'm evaluating the square root of 36, which means this is a positive root. I get a positive 6 answer. That is a perfect square. If I'm solving for x squared, I'm trying to find those unknown values. What could x be? Well, if I'm square rooting, x could be a positive 6 or x could be a negative 6. So here I'm solving for an unknown value. And I've got 2 possibilities. In the first one, I'm evaluating something that is known. I have a square root and I'm simplifying it. So there is a big difference between solving for an unknown variable and just evaluating a radical. So don't just add a plus or minus to any square root you ever see. It's only when you're solving for that unknown value. I know it was a little bit of a longer video today, but hopefully you paid very close attention and you have refreshed your memory on Algebra 1.